Alright everybody, welcome to Unit 2.02 Motion Graphs. We'll be learning about motion graphs today with me. Alright, graphs. I bet you forgot about them, didn't you? You've learned so much in math, but here we are again in physics. So, a graph. Graphs, they have two axes. Y-axis and an x-axis. The y-axis is usually a dependent variable, while the x-axis is usually independent variable. What this means is that y-axis, it depends on x, and x-axis, it doesn't care whatever y does, it just does its own thing. For example, time. Time just continues on without anybody's permission. However, distance, it has to be controlled somehow, some way. It depends on time. So, here you go. Here's a y-axis, x-axis. Horizontal, vertical, easy. Alright, here's an example of a distance time graph. Looks complicated now, but chill out. It'll be easy soon. Alright, so we'll be learning first about distance time graph. So a distance/time graph is used to see the distance of something when compared to something else. For example, seeing the distance of me and the door, or seeing the distance of a car of a distance of someone and a car, or something, I don't know, something like that. The gradient of the line is also the speed or velocity of something, of the object at the time. Alright. So, you notice that the gradient is actually the speed or velocity, as we said right here. Right. How do we calculate speed or velocity? It's right here. The speed triangle. Distance over time equals to speed. And if you mark x as time and y as distance, it basically becomes change in y over change in x. That is distance over time. So these two are basically the same thing. Alright, here's an example. Amin is walking home to Jalan Wat. He stops for a short pee at right here, BC, and then he speeds home. But then he forgot his car. So he thought right here, he sat down and he thought, wow, I'm really stupid. So then he walked back all the way to his office. This graph shows the distance between Amin and his workplace. Alright. So, what is Amin's velocity between A and B? Velocity is basically speed, so we're just calculating his speed. In this graph, the line between A and B has a gradient of 3 kilometers over 5 hours, which is positive 0.6 kilometers per hour. How do we calculate that? Alright, so right here, between B, the point B right here, and the bottom of the graph, we see over here this is 3, and over here this is 0. So 3 minus 0 is 3. That's simple. The next one. So over here, seeing the change right here. The change from here, A, to over here, B. So here is 5, and over here is 0. So 5 minus 0 is 5. So 3 over 5 is 0.6 kilometers per hour. Has to remember to put the positive because this is velocity. Oh yeah, forgot the arrows. Alright, what is Amin's velocity between C and D? The line between C and D has a gradient of 3 kilometers minus 12 kilometers over 8 hours minus 12 hours. That's the gradient. So we simplify that even more. It becomes 6 kilometers over 4 hours equals to a positive 1 over 5 kilometers per hour. We just do that thing again. Just count over here 1. So from point D, which is 12, to point here, which is 3. So 3 minus 12 is 6, and over here is 8. 8 minus 12 equals to 4. So 6 divided by 4 equals 1.5. Alright, the last one. I means velocity between E and F. E and F has a gradient of 0 minus 12 and over 14 hours minus 20 hours. So like right here is 12 and over here is 0. So like 0 minus 12 becomes negative 12. And over here is 14 and over here is 20. So 14 minus 20, that's 6. So negative 12 divided by 6 is negative 2 kilometers an hour. Remember the negative because he's going backwards. Because he's an idiot. Alright. Next one, we're going to be learning about speed-time graphs. Speed-time graph is used to see the speed of something at a given time. The gradient of this graph is also the acceleration of something. So before, something, the gradient of the graph is actually the speed or velocity. Now is the acceleration. How? Let's see. Okay. So acceleration is the change in velocity over change in time. So if this is speed and this is time, so it becomes change in velocity over change in time. It's the same thing. Alright, let's move on. Alright, here's another example. Adam is running a mini marathon. He starts off by steadily increasing his speed until he is running at 16 meters a second. He continues running at this pace until he got tired, right here. And he started to slow down. And this is the end of the race. He barely reached the end of the race. He fell and he actually fainted at the end of the race, which that was a miracle. Anyways, this graph shows Adam's speed. Alright, at the start, what was Adam's acceleration? Right here, point A and point B. So the acceleration is pretty easy to calculate. So let's start with the top here. 16 meters a second. Right here is 0 meters a second, and at the end is 16 meters a second. So 0 minus 16 is 16. Now let's calculate the time. Time, here's 10, and here's 0, and over here is 10. So 10 minus 0, that's 10. So 16 over 10 is 1.6 meters a second squared. You add the square because it's acceleration. Alright, so at the end, what was Adam's acceleration? Now let's do the same thing. We calculate the speed first, which is up here, 16, and down here is 0. So 16 minus 0, that's 16. Okay, down here is 25, and down here is 20. So 25 minus 20, it becomes 5. So 16 over 5 is 3.2 meters a second. But you realize he's actually slowing down, so I put a negative there because, he's slowing down. Alright. That's it, I think. Sorry if it was kind of long and boring. I'm gonna go away now. You should go away too, so bye.